This is Electric Universe Size, and today I have my friends Damien, John, and Andy in my lab.
Here, so it's touching, so what I need to do is make sure that's off, so it won't die. And it's got a vacuum in there. I can feel it pulling on this. So that's how much vacuum was in there. I gotta adjust this because whenever it sucked that air out, it moved the electrode. So stick that one in there. I just want that one to be right above so that it arcs to it. See it on your side? Oops, that might help. Here you go. That's what it's pulling.
How long does it take to fully get it vacuumed?
It seemed like maybe about a minute.
You might want to give it a minute.
I'm gonna give it a minute. There's a sound I kind of hear from the vacuum too that starts to like whine almost, like all right, it's like that's kind of what I hear whenever it's just can't go anymore. I had my first test was with the water bottle. I didn't empty out the water, so it sucked some water in there and mixed up with the oil. So it's been pulled. It started to pull more. So that's only getting 15 before now I'm getting 20. All right, look, now it's right above. That's perfect. I don't want my phone to get blasted, but I'm gonna be brave and leave it up here. All right, ready? Look at the side. Look at the side.
Oh.
See it like pulling it up? And it's creating a mountain formation as it's pulling up the material. It's organizing like a helix. There's like a spiral in there and it starts building up layers. And you start building a mountainside. This is the first time I've done it in a vacuum. Normally it's in just our normal atmosphere. So this is with this
What's it going to end up doing?
it's building a mountain. And eventually, once this vaporizes and dries up all the water, it'll make its connection through the earth to the discharge point and start to form a canyon. And essentially it turns into a river system that connects all these pieces together as it's making its way towards each other. It's quite awesome.
If you had a really super good camera that could pick that up, what it's doing right now, it looks like a butterfly.
Yeah. It
Or
rotates.
a moth. It looks more like a moth, I'm sorry.
The way the electricity is going is it's counter-rotating each other. So it's like little vortices within vortices, like different scale sizes. So you can imagine filaments wrapping around each other going in opposite directions. And how it discharges. So, and It's looking for the most conductive path, so it's organizing these minerals, pulling like the iron mainly, is I think the primary thing that it's pulling from, but it needs that water source. So that water makes it a short path conductive, like a short circuit. So it's always looking for the moisture in the ground. I correlate this to what I see in the sky with the moisture above and the storm systems and where the lightning comes down. Right? We're just seeing a normalized scale of what I think formed this earth. That's kind of what I'm after. Oil smells kind of sweet now. Oil? This vacuum oil?
Oh, it's pumping out all the fumes and everything in there. Right.
Yeah, it's all that. That's all moisture and stuff coming out of the inside. Because right now, it's still vaporizing as it's discharging that plasma arc to that gap. It's vaporizing the water out as well. So every time it does that, it extracts the minerals from that water that's being drawn up, and they get deposited in layers. Just like in geology, you can see all the different sediment layers, right? Okay.
Oh, that would be cool if you move the light bulb a little closer, just using the light up because of the discharge.
Oh yeah.
Is this that type of bulb?
No, but this one, when you first strike it, if it doesn't make a connection, just that initial dissipation will make this faintly flat. Pretty good.
That'd be cool to get a bulb that would actually kind of flow this.
yeah.
While you're doing that.
You should see one of those little tubes that you got.
Which is
Hey, those tubes, they supposedly have a vacuum, right? Have you ordered?
science tube?
They have the neon, the argon.
Yeah.
Those already have a vacuum inside.
Yeah, you know.
What if I use that and put it in a vacuum already? What if I put that vacuum in a vacuum? Would that explode or would it equalize? And then could I do a discharge inside of the vacuum and then not break the glass?
That'd be cool. And if you break the glass, it's
It'd be
okay.
inside
because
this
it's
plastic
inside
and
the-
then it'd be safe.
Yeah, I like that.
I'd probably put my glasses on in that case.
I'm gonna get some glasses. Well, there's glasses right there.
Yeah.
And then I'll bring it back and take it back.
It's a good idea.
Yeah, real quick, and then
So I've sped this part up 2 times, so this is going faster here. But what I've noticed in looking at this discharge is it's doing very similar features to what it does in a normal atmosphere. So to me, the vacuum doesn't really do anything different so far.
See what we're doing now. This is what I was worried about, is that moisture building up on the sides, and I think it's starting to. I'll probably have to evacuate it and wipe it down.
Just evacuate it and let it go.
Evacuate. We should eat!
Yeah, let's
What are we doing? Let's eat! Alright, let's stop this. I don't know, we're just having fun.
maybe you just want to show me
Yeah.
turn it on again.
Here, let's
You can show
empty
me that
this.
anytime. And there's your gases, okay?
Wow, did you see how much it moved?
Alright, so it's the next day and I wanted to look at the results and see what we can see here. So that's quite the circular pattern with a large mound on the bottom left and a little tiny mound on the top. Let's go in for a closer look. Well, there it is. That's what I made last night. Again, you know, the spark gap was, that's too big of a jump right there, but when I put a vacuum on, it sucks all the pressure out. It sucks all the air out, and you saw it, the electrode drops. Anyway, thought that is pretty cool. Alright, so I pulled it out of the chamber so I could look at it a little easier and kind of notice. So that this corner over here, just about right here, was where that other electrode was. And I don't know if it's me or maybe I'm just seeing what I want to see again, but it looks like this charge went around this way and was pulling, just organizing this mud in a certain fashion. This side over here, when I first saw the discharge in the video, started pulling material towards that electrode. And so it's almost like this is a little valley entrance. I still clearly see the defined walls of a hexagon on the far outside. While it was discharging, and it was dry, it forms that smaller hex shape too, but it definitely does seem like there's some geometry involved in every time it recreates these formations. I look at other craters too on Earth or on moons, and sometimes there's just this little, it's like a little rile that leads in, and just looking at the shape of the mud behind and how this water kind of path, the path this water took underneath is pretty cool too. All right, well, what I think I'm going to do is put the lid on for now and come back with both my 3000 and 10,000 transformers and discharge at the same time and see if we can get two different potential anomalies to finish out this geological landscape here through electricity. That was fun hanging out. We'll do it again soon.